Imagine spending millions of dollars building a state-of-the-art corporate computer network in 1993. You have the most expensive mainframe servers, the best information technology administrators, and a perfectly secure closed-loop system designed exclusively for high-speed financial databases. Now imagine watching that entire multi-million-dollar infrastructure violently crash and burn to the ground, not because of a sophisticated Russian cyber attack, but because Dave, from accounting, downloaded a 2-megabyte file called Doom and challenged the marketing department to a death match. In the world of cybersecurity, we call this a massive distributed denial of service attack. But in the world of 1990s, software engineering, we call it the greatest digital revolution in human history. Welcome to another episode of History Glitch, where we usually analyze the catastrophic failures of aerospace programs and collapsing steel bridges. Today we are looking at a deliberate structural overload. We are dissecting the exact moments when two young programmers completely hijacked the architecture of the personal computer and inadvertently wrote a piece of software so mathematically aggressive that it literally broke the early internet. Based on the legendary book Masters of Doom by David Kushner, we are going to explore how John Carmack and John Romero bypassed the absolute laws of physics. To understand this massive glitch, you have to look at the personal computer in 1990 as a rigid, unyielding operating system. It was a boring beige box sitting on a desk designed strictly for spreadsheets and word processing. It had a sluggish central processing unit and a graphics card that could barely draw static text. If you wanted smooth, fast-paced scrolling graphics, you played on a dedicated custom-built hardware system like a Nintendo. The physical architecture of the PC simply could not mathematically redraw an entire screen of pixels fast enough to simulate smooth horizontal movement without stuttering, freezing, and completely crashing the system. In computer science, this is a hard hardware limit, but a young brilliant programmer named John Carmack viewed hardware limitations not as absolute laws, but as poorly optimized legacy code waiting to be cracked. Carmack engineered a revolutionary software hack called adaptive tile refresh. Instead of forcing the computer to painstakingly redraw every single pixel on the screen, every single frame which would instantly overload the processor, Carmack wrote an elegant algorithm. His code only redrew the specific pixels that were actually changing on the edges of the screen, while leaving the rest of the memory completely static. This brilliantly efficient piece of code completely bypassed the physical limitations of the motherboard, forcing the boring business machine to suddenly render smooth, lightning-fast arcade graphics. This single mathematical glitch birthed ID software and completely changed the trajectory of the digital world. But Carmack and his volatile visionary design partner John Romero were not satisfied with two-dimensional scrolling. They wanted to push the hardware into the impossible realm of three-dimensional space. True three-dimensional rendering was computationally impossible for a 1992 computer to process in real time. So Carmack wrote an algorithm that cast invisible mathematical rays from the player's virtual eyes, measuring the distance to two-dimensional walls and mathematically scaling them on the screen to create a perfect optical illusion of three-dimensional depth. It was a masterpiece of software optimization, running a highly complex simulation on incredibly weak hardware. It was essentially tricking the graphics card into rendering a reality that did not actually exist. But the ultimate system overload was unleashed in 1993 with the release of Doom. The true historical glitch of Doom was not its graphics, but its multiplayer component known as Deathmatch. Carmack had programmed the game engine to allow multiple computers to connect over local area networks, transferring complex packet data in real time. But the developers drastically underestimated how wildly addictive and brutally data-heavy their creation actually was. When Doom was released as shareware, it spread across the early internet like a highly aggressive biological virus. Within days, office workers, engineers, and university students immediately began playing multiplayer matches over their institutions' local area networks. The Doom software was so incredibly data-intensive, transmitting constant high-speed positional updates and action commands, that it flooded the bandwidth pipes. The sheer volume of network packets instantly overwhelmed the infrastructure. Massive million-dollar mainframe servers at companies like Intel and universities across the world completely crashed under the immense, uncalculated data load of people playing a video game. Information technology administrators were absolutely terrified. They were watching their expensive, carefully maintained business networks being violently brought to their knees. Network administrators were forced to issue emergency global bans, writing specific software programs simply to hunt down and delete the game from their servers just to keep their infrastructure from completely collapsing. Doom had become the most disruptive piece of software in human history, but the relentless, unyielding drive to push the hardware even further eventually caused a fatal crash within the human operating system of ID software itself. For their next project, Quake Carmack wanted to abandon optical illusions and build a true three-dimensional engine utilizing client-server architecture. The mathematical complexity of the Quake engine was staggering. The development team entered an agonizing period of endless crunch, working 20-hour days, sleeping under their desks, staring at glowing monitors until their eyes bled. The code became a monstrous, bloated beast that was constantly crashing. The intense pressure to optimize the engine fractured the relationship between the two founders. Carmack, the cold, logical machine intelligence, clashed violently with Romero, the chaotic, ambitious artist. The Quake development cycle was a massive psychological system failure, resulting in Romero being fired and the original magic of ID software being permanently shattered. The story of the Masters of Doom is the ultimate testament to the terrifying power of optimization. It proves that software is never truly limited by the hardware it runs on. It is only limited by the imagination and the sanity of the engineers writing the code. They bypassed the physical rules of the machine, they crashed the global networks of the corporate world, and ultimately they overclocked their own human limits until the system violently broke apart, leaving behind a digital legacy that forever altered the architecture of the modern world.